to my channel, and today we will together solve the LeetCode daily problem. And so another like bit manipulation problem, and for the bit manipulation problem it is always like hard question because we need to find out the the observation to solve this problem. Because if we look into the constraint, somehow like the constraint always like if we try to just use the ON square, it is very difficult to solve. However, like normally for the bitwise bitwise manipulation, and then somehow like we need to come up with the strategies to just use the ON by 32, where 32 is the number of the bits we use in the system to represent a number. Okay, so how can we solve today's problem, and what is our intuition and observation? So in here like we have the number 1, 2 and 4, for example. Instead of doing like the so you can see that if you traverse like this array from the first element to the last element, that is very hard for you to track, because like for example like this is the solve operation if you solve 1, 2 and 4, for example in this case. And for example like for now this represent for the entire subarray, right? It can be the subarray by itself. However, like what if you just consider the 2 and 4 in here? How can you exclude this one here? This is right impossible, right? Or like it will take a lot of time. So that's why this approach is not feasible. You can try it by yourself. And today yeah, so here like we will introduce a case like how can we solve it. Okay, so let's think in another way. For example, like for now I will consider the 4 first, and then from the 4 I will consider the 4 to combine with all of the previous the subarray. For example like in here we have 4, right? And 4 can combine with 2, 4 can combine with 1, 2, or like 4 can combine with itself, which is the 4. Okay, and here like we will do the solve operation, and of course like here like all of the elements in here it needs to take the operation by itself. For example like 2 and so 2, here like 1 so 2, and in here that is the 4 so 4, right? Okay, yeah, so what is our observation here and how it is related to the bits? So we can see that like for the first case, for example, if I fix the 4, and then what is the number representation for 4 in terms of the bit? So here like I have the representation for the 32 bits of the 4. This is the bit position. Okay, this is the most significant bit, and then so on and so forth. We have for us we have the bit second, this is the 1, and bit 1 which is the 0, and bit 0 which is the 0. Okay, so here we have the representation of 4. Representation of 2, for example, for now we will have the combination of 4, 2, for example. This one is a combination of 4, 2. Okay, 4, 2. Okay, so what is the 2? 2 is 0, 0, and here we have 0, 1 and 0. Okay, so here like we will solve these two number. Okay, and then what is our result? And so the result in here like you can see that when we are two numbers, right? And then always like it will replace the bit 0 by the bit 1, for example, in here, and this bit 1 will replace this one. And so here like we can have the result like 0, 0 and 1, 1, 0. So this is what is this number? That is the 6. Okay, so this is the 6. Okay, so another example, for example like 4 and 2 and 1, right? And then so what is a 4? Again, that is like 1, 0, 0, 2, 0, 0, 0, 1, 0, and 0 here, 0 here, until 0, 0, 1. Okay, so you can see that in here all of these three, like the 3 bits will become 1. So finally we have 0, 0 and 0. Sorry, this one is 1, 1 and 1. This is a 7, right? Somehow like we have the result in here. Okay, so one of the observation in here you can see in here is that if you fix the number 4, if you fix the number 4, and then so what does this mean? what is the OR action with other numbers. So it means that when you try to OR with other number, if the bit position that is the 1, it will never be changed. It will never be have a change. So that is a reason why like yeah, so in here, so you can it means that like in here we have like if we solve with the new number, and then that new number have the bit 1, and then the current number have bit 0, it will introduce bit 1 to the current position, for example. So it means that like somehow like how many cases we have to have the like to replace the bit 1 in here, sorry, bit 0 in here. We have at most 32 cases. We have at most 32 cases. Why? Because we only have the 32 bits to represent a number. And the worst case when it has a 32, it means that like all of the numbers here are 0, and then we keep all with the new numbers in the future, and then the 0 number here will be replaced by the new bit 1, right? Okay, so that is the case, and then that is a reason why somehow like we can see that like for any kind of the previous subarray, in this case we have the subarray this one, right? The subarray this one, and then the result of the subarray in here. I mean that, for example, 2 saw 1 or 2 saw 2 by itself, it cannot be it cannot introduce more cases rather than 32 cases in here, because this is just the things like we keep adding the number 1 into the empty position of the bits for the number 4. Okay. Okay, so how can we solve this problem efficiently? Okay, so here we need a little bit knowledge about the set, because like today problem is not like the hash map, because hash map is not efficient in today because we need to delete it anyway. So for example, like I want to introduce the previous value, for example, because like this one will hold the value, for example, like 1 saw 2, for example, for the 1 2, and then like yeah, so on and so forth. This is will keep the previous value of the previous array. Okay, and so in here we let's say that this one is the 0, right? And then so let's say that we will start from the first number number 1. So in here we have the current, which is the 1, right? And then we can have the answer directly, introduce the answer, and that is the empty set, for example. Okay, so for the first element, and then so we can see that because like previously we have like we have the 0 value, so we can like yeah, we can get the or this value with the 0, so it will result in the this one, the 1 or 0, right? 1 0, and then so we have the previous, because like we need to update this one when we move into the next index, which is the value of 2. So here like we have previous one will be 1, and then so because like we one can itself make a new subarray by itself, right? And then so we need to make sure that this one we will check the subarray by itself as well, so that will result in 1. Okay, so for now, how can we update the answer? The answer, it will be equal to like answer, and we will, this is the operation for the set. It means that we will get the previous as well, and then so this one, for now the answer become 1. Okay, we have the number 1 first. Okay, so for the second iteration, we move here. Okay, so for the number 2, so here we have the previous, which is the 1, right? And then what is the current value? That is a 2, right? And then so in here we have we can update this one, and then somehow like we have the previous value that is equal to 2 saw 1, right? 2 saw 1 is what? Is the 3. That is the 3. We put the 3 here, and then we check with the current number here to see that like if it's differ from the things we have in the set. So this one will lead to the 2 and 3, right? Okay, so here like we can update the answer. That is the previously that is the 1, right? And then the answer will be 1, and then we will get the 2 3, and then it will introduce 2 new elements into our set, right? For now it is 1 2 and 3. Okay, so for the last iteration, so we are here, and then our previous number, I mean the previous value for the subarray, that is the 2 and 3, right? And then so the current value in here we have that is a 4, and then we can have combination here, right? And then this one leads to other 2 elements, that is the 4 and 2, that is the 6, 4 and 3, 4 and 3, it would be 7. So we have the 2 elements in the set, and then so we need to check with the current value because it also can make a new value by itself. So we have the 4 6 and 7. So for now we will update the answer. That would be like 1 2 and 3, and then so for now the answer that would be like 1 2 and 3, and then we will see that would be 4 6 and 7, right? Because like we get the previous value, so it will result in 1 2 3 4 and 6 and 7. Okay, so we can check here. That is exactly the results we have here, right? Okay, yeah, so we will try to this is not our operation, okay? So this is the operation of the set. Yeah, this is the operation of the set, so don't be confused, right? Don't be confused. It means that somehow like we will merge two sets if they contain the different elements. This is actually the saw operation. In here is saw operation. Okay, our saw operation is here. Okay, so for now we will program it together. I think that in the programming it would be fine. It can show you all the things easily. Okay, so for now we need to define the return value at the set first, and then we have the previous value. That is we will get this one will be the answer we have. Okay, so here like we have the previous value, and so we will get the current value in the array, and then so we need to initialize because like we need to consider the previous value, right? So next I will put this one as the temporary, or the next value. This one will be temporary variable for us to assign to the previous value here after every iteration. So we will create an empty set for this, and then we will go through all of the previous value, and then we will get the next one dot add. We will add the new elements, right? This is the operation in here. We will try to add this into the previous value. Here like we will add the value, and then we solve with what? With the current value, right? Here like we will get the current value solve with value. Okay, so here, and then finally we get the next of file. and then we will add the current value to represent for this one, because like each element can be subarray by itself. So we just check okay, and after that we get the previous vowels and we assign it to the next vowel, and we get the red vowels. It will be this is the set array. Okay, that is the not operation, the sort operation, or operation. And then so we here we just need to return the size of the red vowels. Okay, so look like it's good, and then somehow like it can help us to defeat 80%. Yeah, I think like we are here. This is good. Yeah, so I think that's all the things for our today problem, and I hope that maybe our explanation today is useful for you and help you to solve your like daily problem. Yeah, so here like if you like my video, and if you want to encourage me to do like make more videos for you in the future, please give me the comment or like give me a subscribe. It encouraged me a lot. And so again, thank you so much for watching my video, and see you next time.